Hello, Algebra 2. Here's the second part of the graphing where we're going to put everything together. So we're going to be doing all four transformations on the same graph. And I realize this can be quite challenging. So it's not going to be as long as the other video because we're just going to be doing example after example after example. Okay, so let's revisit. Up here you have the general form with all the transformations. This first C, which sometimes they add at the end of the function, represents your new sinusoidal axis. That is where your x-axis gets moved up or down depending on what C is. A represents your amplitude. So remember, that's the distance from your sinusoidal, how high, how low you go. B is always going to be related to the period. So it represents how many cycles you can complete in 2 pi. And to find the actual period, you always go 2 pi divided by b. That's the distance it takes to complete one cycle. And then lastly, we have D. That tells you on the x-axis where you are going to start. And so what I have here are some, my guidelines for the steps I go through when I'm graphing. I identify the new sinusoidal axis and I draw it. I mark off my y-axis with my highs and my lows. Then I mark off my x-axis where I start, where I end, my average ways, my quarter ways, and then I draw a cycle. For what we're doing, you can just draw one cycle. Let's kind of keep it real. All right, so -2 in this first example. So this is going to be my what we call a vertical translation. So I'm going to put that over there. Notice my amplitude, that's the A value. That's going to be 3. The period is going to be 2 pi divided by 2, which is pi. That tells me that I can complete one pattern of my cycle, one pattern of the function, one cycle in pi. And where am I going to start? That's what this D value tells you. Remember, it always kind of works the opposite. So you're going to start at 30 degrees. I realize this one is in degrees. It's not bad to know how to do both. Degrees actually is easier. So let's start this off. So I said identify your new sinusoidal. So that's -2. So I'm going to always label your axes. I'm a real stickler for that. And then I'm going to do this little dotted line. So this is like your new x-axis. That's my new sinusoidal axis. Now if I have an amplitude of 3, it means I'm going to add 3 to -2. You basically add and subtract to your sinusoidal. So this will bring me up to 1, and it's going to 1, 2, 3, bring me down to a -5. That's going to be where the highs and the lows of my graph fall. So I like to do the little dotted line because I don't do these on grid. Okay, so we have our y-axis. We've done number 1, we've done number 2. Now we need to label our x-axis. And you always label the actual axes. You don't label those yellow dotted lines I gave you. So we're starting at 30 degrees. And I just realized I made a little mistake over here. If we're in degree mode, it's not 2 pi, it's 360. 360 divided by 2 is 180. So what we really want is 180. Now, we don't usually ask for this, but what I always tell you to do is, so this is where I start. You always start at your phase displacement. That tells you where you slid along the x-axis. I always like to put down here also, where do I end? So if I'm going to travel 180 degrees starting at 30, I add 180 to this. So I'm going to end at 210. So I know where I'm starting, I know where I'm ending. Now I'm going to start taking averages. 30 plus 210 is 240. half of that is 120. So that would be my midway point. 30 plus 120 is 150. Half of that is 75. Notice that each little segment is going to be a distance of 45 degrees now. 120 plus 45 degrees is 165. And that's also another way, once you figure out what that distance of each quarter. So now we're really ready to graph this. This is a sine graph. So remember that sine always starts on the sinusoidal, then it goes to the high, then it goes to the sinusoidal, then it goes to the low, then it goes to your sinusoidal. And that puts it all together. All right, let's try another one. Now we're back to radians. So we have here 1 is my vertical translation, 2 is my amplitude, B in this case is 1, and since we do have radians here, 2 pi over 1 tells me that my period will be 2 pi, but we will be starting at pi over 2, the D value. Okay, so my vertical translation here is going to be at 1, and I'm going to add 2 to that. That puts me at 3, and that puts me at -1. So now I'm going to do my little dotted lines to help me with my hitting my point. Oh. Why is it you're not gonna? Okay, so here's a reiteration of the different transformations. Your vertical shift, which is your new sinusoidal amplitude. Now this I didn't actually talk about. Your amplitude is always positive because it's a distance. So if you happen to see a negative in front of your amplitude, like on example F, what that means, the negative is a reflection. It's not part of your amplitude. So don't ever give a negative amplitude. And then you have your phase shifts and your new period. All right, now this one we're not going to fill out all the stuff, but we are going to go through the process just like we did in the last one. So this 1 here represents my new sinusoidal with an amplitude of 2, so that's going to take me up to 3, down to a -1, and I'm still going to do my dotted lines. And I'm then going to, this one is nice because your period is going to be 2 pi, and we get to start at 0, so that's going to make it really nice. So I'm starting at 0, I'm ending at 2 pi, which means halfway is pi, so this is pi over 2 and 3 pi over 2, just like the unit circle. And because this is cosine, we are going to start high, then sinusoidal, low, sinusoidal, high, and draw the graph. All right, so if you can really get those 5 points down, everything else will just kind of connect the dots. So on example B, we have, now it's nice, my sinusoidal is just going to be the x-axis. I have an amplitude of a half, so that means I'm only coming up a half and I'm going down a half. And so I can draw my little dotted line. And then, oops, where did all my pens go? So this 2 in front of the theta, that's your 2 pi divided by 2, tells me my period now is going to be pi. So I have no phase shift, so I'm going to start at 0. I'm going to end at pi, so half of that is pi over 2, half of that is pi over 4, and this is going to be 3 pi over 4. If you look at a unit circle, you can see those 45-degree differences. This is a sine graph, so I start on the sinusoidal. I'm going to go then up, sinusoidal, down, sinusoidal, and that is it. Voila. Alrighty, let's go on. This next one, we have, again, x-axis gets to be our sinusoidal because there's no vertical shift, but we do have an amplitude of 3. So I'll do an amplitude of 3 with my dotted line so I can find my highs and my lows. And now to mark off my x-axis, notice the 2 again. Now this one is also in degrees. So we're going to do 360 instead of 2 pi divided by b. Tells me it only takes me 180 degrees for my period. That's the distance it would take to complete one cycle. Where am I going to start that cycle? I'm going to start it at 30 degrees. So that means 180 degrees later puts me at 210 because that's a distance of 180. All right, halfway between those, add those. That's 240 divided by 2, which is 120. Half of 150. We have these same numbers on the other side. And so again, those 45 degree distance, there we go. So it's a, oh, this is a cosine. So at 30 degrees, we start high, sinusoidal, low, sinusoidal, high, and we graph. Awesome. Okay. And again, these are periodic functions because the graph keeps going and cycling around like a Ferris wheel, like the tides, like the moon, anything that is cyclical. This could be a representation. Okay, example D. We now are back to a sinusoidal that is at 2 with an amplitude of 1. Oh, okay, so actually let me revisit this. Let's put 2 here and make it kind of a big 1 so that my graph isn't too crunched. I'm still going to do my little dotted lines. And now let's label our axes. So we're going to, that 3, oh, we're still in degrees. So 360 divided by 3 is 120 degrees. That is my period. That is the distance it takes to complete one cycle. Where am I going to start? I'm going to start now at negative 60 degrees. So if I go 120 degrees, that is going to put me at a positive 60 degrees. So because it's going to be straddling the y-axis, I'm going to spread this out a little. So here's negative 60. 120 degrees later would put me at 60. So there's some nice symmetry. The middle point is 0. This will be negative 30, and this will be 30. You can see how degrees is actually a little easier for these. Okay, so now we're ready to graph. This is a sine. So it starts on the sinusoidal, then at negative 30 we go up, at 0 we're on the sinusoidal, 30 we're down here, and we finish at 60. So one cycle would look like that. All right, hope you're still with me. I hope it's starting to kind of make a little sense. So down here, we have 1 for our new sinusoidal with an amplitude of 2, so that's going to put me up at 3, down at a negative 1. So now that I have that mapped out, give myself my little dotted lines. And now the 3, again we're in degrees, so 360 divided by the b value tells me I can complete one cycle in 120 degrees. But where am I going to start that cycle is at 45 degrees, positive 45. So 120 plus 45 is going to be 165 because that's going to be a distance of 120 degrees. It takes 120 to complete one cycle. So now we're going to have to do some averages. So I'm going to use my calculator here. 45 plus 165 and divide that by 2. That gives me 105. 105 plus 45 is 150, so half of that is 75. Notice now then each segment is a distance of 30. You can also just take this and divide by 4, so you can see each segment will be 30 degrees, so this will be 135 degrees. All right, so now we do our graph. Once you have everything labeled, it is a sine. Sine starts on the sinusoidal, it goes high, sinusoidal, goes low, sinusoidal, and then we connect the dots. All right, last one. Dun, da, da. So 2 is going to be my new sinusoidal with an amplitude of 1. So this, oops, that's a negative. Why did I do a -2? Sorry, my brain took a little vacation there. Okay, I'm up here at 2, and I'm going to go up to 3, down to 1. So those are going to be my highs, lows, and my sinusoidal. Ooh, I'm going to have to go back too. Let's do this. All right. And so I noticed that 360, since this is in degrees here, divided by 2 is 180. So it'll take me 180 degrees to complete my cycle. That means there'll be 180 divided by 4 is 45 degrees. So each segment's going to be 45 degrees apart. We're going to start, whoa, why did I lose my pen? We're going to start at a -90, and 180 degrees later is going to put me at 90. So this one is very nicely symmetric too. So this is 0, -45, 45. Now, what I want you to realize though, this one, cosine, has a negative in front. So it means instead of starting high, it's going to be reflected. It's going to start low. So my low is at 1. So here I'm going to start low, hit the sinusoidal, hit the high, sinusoidal, hit the low. So it's your handlebar that is upside down. Da, da, da. And there you go. There is Intro to Graphing.